start. Hello everyone and welcome to our another workshop in the Private series. Today we have a special workshop on deep dive. With us is Tyler Adams, the CEO from COZ. Tyler, please tell us some introduction about yourself and your work.
Sure. So I'll focus more on what's relevant to this project. So I've been a developer in the Neo ecosystem for about 5 years now. I believe that I've hosted more hackathons in this ecosystem than anybody in the history of shares of Neo, including both Neo Legacy and Neo N3. I've traveled all over. I think I've done hackathons and workshops in about 10 or 11 different countries, all Neo focused, some of which had hundreds of participants or more live. And this props project, while it's pushing for and it's kind of branded towards metaverse applications, what it really has is I've tried to distill down all of the areas that participants in these hackathons have had issues with and resolve them. So nobody has these problems out of the box. People can just pull down this code and they can start building an application. So I tried to kind of smooth over a lot of the issues that I've encountered with people just in my experiences with them. And then, in addition to that, we've also worked on some of the NFT stuff. We've pushed out these Puppet NFTs as well, which are really meant to seed this ecosystem and give people some additional features that they can build on top of for the various users that exist in our community. So that's really the goal here. So we, jumping into the project, there are really 3 different focuses. The first one is for contract developers, and this is a very explicit one, right? We've built out a library, which is pretty small right now, of smart contracts, which expose some new functionality that's on a higher level for developers. So, for example, with the DICE contract, we've wrapped the random number generator in Neo so that it has some more easy to interpret and implement features. And then we've also added a few other contracts as well for kind of contract developers specifically. We have a couple projects that we're going to also release, which significantly improve that capability in the near future. We have some people in our team that are working pretty hard on that, which I'm pretty optimistic that we'll be seeing. Right now we have 4 smart contracts in this project. I'm expecting that we'll probably have 100 maybe in the next 12 to 24 months that we're kind of seeded by this initiative. I'm relatively confident of that. The other area that hackathon participants and app developers have had issues with over the years is in integration. So in this project, in addition to the smart contracts, we also provide the source as well as an NPM distributed TypeScript SDK that people can grab and play with for directly integrating with smart contracts. And then the third is for an entire dApp development environment, right? So what we've really done here, and we can start talking about the code more. I think that's probably the best way to go about this. So what we've done with this project, and this is available on the City of Zion GitHub, what we've effectively done is put an entire decentralized application scaffold in a GitHub project. And then we've also built out a lot of utility scripts that help people get started. So what used to probably take new developers dozens of hours of debugging, we've completely implemented for you. So, if you're a Polaris Hackathon participant or you're looking to work on a DApp, build out an application, whether it's NFT or metaverse related or not, this is, I would actually say this is objectively the fastest way to start building a decentralized application in the Neo ecosystem. And I tested it last night. I effectively got to the point where I was doing system level testing on a game smart contract in an afternoon, right? Near future enhancements with the SDK will be adding Wallet Connect support. So natively, people have Wallet Connect integration with their applications as well if they use this ecosystem. So that's kind of the goal for the project. And I think we can probably start jumping through and doing a bit of an overview of the code and how some of the features behave and work. The other thing I guess I should probably mention right now is that we do have a documentation website. It is at props.coz.io. And it's a little sparse right now, but we'll be adding substantially to it in the near future. And the goal would be to intercept some of these hackathon participants. I should also mention, people have development questions, or they get stuck. Definitely reach out either on the Neo Discord or the Props Discord, or even on Reddit or Telegram, and they all will get forwarded correctly. The ecosystem is really good at that. So, right. So getting started on this, I guess I should also mention that our environment assumes a few things. The first one is that you have Python, I believe at least 3.7 installed, and you also have Neo Express installed. A lot of the coverage and the way to set up like the Python environment, for example, is covered in our Python smart contract workshop, which we gave, I believe it was last week. This workshop is kind of a continuation of that. So there's some expectation that you already have NeoBoa installed or you have like a virtual environment with that set up. If you don't, I would recommend taking a look at that workshop. If there are any questions, again, kind of feed them directly into the support channels and we'll answer them. Okay, so to get started on this, I guess I can go through an overview of the directories here. We have a contracts directory, and this is going to hold all of your smart contracts. And in this case, right now, we have our props smart contracts, which can be referenced. So you'll see we have a collection, a dice, a generator, a puppet, and then there's this one that I wrote yesterday that we can talk about a little bit, and it's a turn-based game. Okay. Inside, right, here's your BOA smart contract for a collection, and this is in WebStorm, so it's not going to be nice and pretty, but for this, it's okay. We'll go to the contracts a little bit shortly. For dice, right, it's kind of the same structure. Generator, you'll see all of the smart contracts are the same kind of structure. If you are writing a smart contract, the best or the fastest way to do this, and I'll push an update with a template contract, I think that might be the easiest, is actually in the props ecosystem just to copy and paste one of these directories and change the code. the assumption here is that for dApp developers, when you're getting started, you're just going to literally copy stuff from what already exists, and then we'll handle it in the scripts. Okay. So, if we wanted to create a new smart contract, we may say with the dice one, we would just copy the directory and say my new contract, and it's Python, so we'll go like that, right? So now I have my new contract, and I can write my smart contract. Okay. And the reason I'm mentioning this, and I'm going to get rid of it, because I don't really want that contract, and that's not really the focus of this meeting or this workshop. The reason I want to do it that way is, and you don't have to, we have a deployment script here, and I'm going to show that to you in a second. And that deployment script can either take in a directory path to a specific folder to deploy a smart contract, or by default, it will deploy every smart contract in the contracts directory. And one of the reasons we have these scripts, I should also add here, these scripts will work on every network. We'll be demoing right now on Neo Express, because there's an assumption that you're going to go through a development kind of cycle here. When you're ready to deploy to like testnet or mainnet, the same scripts work. So all you're doing, you're ideally changing your private key, which is a command line or argument, and then you're changing your node that you're targeting. And you can hit mainnet and deploy your smart contracts automatically. So I'm going to show you that really quickly. So, and just to make sure, so I'm running NeoXP reset force, just to make sure everything is nice and clean. And I'm going to run the Neo Express node with a 1 second interval. I know in the previous Python workshop, I said, I like running them in 5 seconds for workshops. That's generally true. However, there's so many contract invocations that are going to happen in this that it would take a long time, potentially, for us to run it that way if I wanted to show you what I wanted to show you. So, or if I could show you what I want to show you. So we're running here. And then I'm going to split this vertically just so you can see what's going on over here and what I'm typing. So you can see we're running, and then I'm going to run just like before, policy sync, mainnet, Genesis. And what this is going to do, this command I'm running now, it's going to pull down all of the policies from mainnet. So, like the storage fee, the Oracle fees, the base fee, things like that, so that all of our fees are aligned. So the costs are somewhat representative of the network. So we're going to run that. Okay, and you'll notice, and it's already off the screen here, but there's our one transaction that set the policy, and then we're going to transfer gas to not the Genesis account. So in props, we already have a wallet configured with the ecosystem, and it's alias to COZ lowercase. And that's the wallet that we can use for development. The reason for transferring the tokens out of the Genesis account is that when you're in a different network like testnet or mainnet, you're not working with the Genesis account. You're working with a secondary account, which has limited resources. So while it may be easier to work with the Genesis account for development, it introduces some room for error when you get into a production environment and you need to deploy. So it's a little better just from a workflow perspective to use a secondary account for that. The Genesis account, like if you do happen to deploy your contract with the Genesis account, it's a lot more exposed because everybody has that account, as opposed to somebody who has to like dig around for it, right? So we're going to do NeoXP transfer, and we're going to grab a bunch of gas, and we're going to transfer it from Genesis, if I can type it right, to COZ. Okay. And you've stopped tracking. Okay. So now we have our gas. So we're basically ready to develop now. Okay. Now I'm going to show you the deployment. So you can imagine if you're writing smart contracts and you have a new one in that directory and you want to deploy it, or you have maybe 4 or 5 smart contracts that you've written in an ecosystem similar to Prost, where we have 4 smart contracts and they all speak to each other. Right? I'm going to deploy it. So in this case, right, because it's an entire DApp development environment, we have the Python smart contracts, and then we also run Node for the application development or the front end. So, and that's what most of our scripts are written in. So these Neon.js, they're fully portable to web hosting as well if people wanted to have a web deployment, for example. But we're going to run this, and you'll notice that I'm going to get an error. Did I not transfer gas? Insufficient gas. Okay. Did I not transfer gas here? Here. I think I have too many zeros. Try that again. All right. So what it's going to spit out here, and I'm going to explain what's going on here because there's an important application development concept here. And then I'm going to show you the opposite, the alternative as well. So here we have our 5 smart contracts now, right? They're listed out as well as their script hashes. And I'm assuming most of the people here are familiar with this. The script hash is kind of your pointer to the smart contract when you want to do a contract invocation, right? Whether that's through a contract call, meaning in the smart contract, or from an application that's outside or off chain. Okay, so these are very important. In our SDK, we've actually built them in. So you can actually go in, and these are also published in the documentation. You can go in and you can view them in any of the high-level smart contracts. You can see here for Puppet, for example, which is our NFT contract that we've airdropped to everybody, extend functionality of everybody, all the voters. You can see that we have the script hashes built in as well as the RPC nodes so that it's really easy to interface with them. And then when we get to the SDK side, I'll get to that a little bit. You'll also notice the gas consumed, right? Now, something that's important here is that you'll notice the deployment showed up first and then the gas was consumed after. That's because in this specific script, and I would recommend that developers investigate this if they're looking at ways to implement contract invocations, right? We actually run the deployment asynchronously. So what we do is we iterate over every smart contract and we run the deploy script and we aggregate all the transaction IDs and then we do a sleep for them to publish and then we grab the results later instead of serially going through the deployments, right? Since especially if you're doing a lot of deployments on mainnet or a lot of invocations on mainnet with a 15-second block time, if you're doing 1,000 contract invocations, it's going to take a long time to do. There are a couple other ways of improving the speed, but I'm not going to get into those right now. They also sometimes cause issues with ecosystem tools, so we won't get into those. Anyways, my contracts are deployed. Now I'm going to show you what it looks like to have the other one. So we're going to do another script here, and it's an initialized script. While that's running, I'm going to walk you through some of the other kind of high-level features and what the stuff does, since our documentation isn't as good as it probably should be for developers. So what this script is going to do is it primes all of the smart contracts that are in the props ecosystem. And what I mean by that is on this project, traditionally in software development, we've been talking about props as a package. It's kind of a package manager, right? We have these software packages that we distribute. It's like that, but there's also the concept of statefulness. So we actually have decentralized application packages. And in this case, that's what these smart contracts are, right? They're basically decentralized application packages. So there's storage associated with them as well. They're stateful. And this initialized script is effectively preloading all of the storage with values which are representative of the mainnet storage. Now, as I mentioned before, we have a couple initiatives which will kind of improve a lot of the props experience. That's one of them, right? So the idea that you can actually pull the script and storage down from mainnet directly into your development environment and start developing with it using a contract API is where we're going, right? So all of this experience that we're working on right now, and it's initializing and spinning up these tools, that's gonna go away. Basically, it'll just be automatic, just like when you run like npm install. It'll be the same thing, but it'll be with smart contracts and storage, right? So what you're seeing here is kind of the same thing you saw before. It's going through a bunch of collections and generators, and it's loading storage with this contract storage with this content. Okay. And you'll notice it's taking a lot longer. That's because these scripts are actually not using that asynchronous architecture. They are serially going through and deploying and then verifying the deployment on each one. Okay, so just to show you an example of the differences there. Okay. Now I'm going to go into a little detail before we get to the next step about what each contract can do and what some of the features are. I should note, and they're not complete, but I can get that up hopefully today, along with the turn-based example in our documentation, and I'll show you exactly where to find this so that Okay, so here's our docs, and I'll mention that pretty much everything I'm going through today is in the documentation, and to some degree of maturity. If there's something that's not clear, that's missing, please mention it, and we can try to prioritize getting it up. Robert, I know you've requested some enhancements, but you'll see here, I'm effectively just recreating this. This is the next step that we'll get to, where we mint a bunch of puppets. I want to talk to the contracts a little bit. So if you're not familiar with contracts, and I know in the last workshop, if you attended it, I went through this. Contract calls are an important thing in the props ecosystem, because the idea is that you have these decentralized application packages that exist in your ecosystem. How do you interface with them, both from a smart contract and from which is kind of decentralized architecture, as well as from a client application, right? So on the client application side, we have the SDK, the TypeScript SDK. On the contract side, we use this syntax in BOA. And I've gone through on most of these and I've broken out how to do that in the docs. So if you'll notice here, and I'm going to show you, I wish I could show my entire screen so I could show two windows. This is effectively the public API definition for one of the smart contracts or one of the props. So this is the collection prop. This is every public flagged method in the smart contract. Okay. So these are all the exposed methods that people can call. You can copy and paste this code directly into a BOA smart contract. All you need to do is replace the script hash to make sure it points to the correct location on your network. And then you can start using the collection prop as if it were any other native class in your smart contract. Okay. One of the improvements we're working on is the ability to just directly import them without having to include this, but that'll show up in the near future. And you'll notice with Dice, it's the same thing. So here, these are the publicly exposed methods for Dice. For the Dice contract, all you do is change your script hash for the target network and import it. On some of the contracts, we've also included an internal import. So if you're in BOA, you can directly import the methods and use them natively in the contract as well. Okay, so that'll pull the code directly in and use it. That also applies to Generator and Puppet. You can directly import them as well to get access to the native classes. We won't go into detail on those in this specific workshop, though. Okay. So now let's talk about what collections and dice are. The dice one is probably a little more straightforward. It's a random number generator with some extra features on top, right? As I mentioned, it effectively wraps the random number generator feature of the Neo N3 blockchain. The collection contract has a number of features that are kind of interesting depending on what you're doing. Sometimes they're very helpful, sometimes they're not. I'm going to switch back now to the code to show you what that looks like. The collections contract is effectively it's storing an array with some metadata. That's really what it does, right? It's not a complicated contract. I'd actually recommend people look at it if you're developing or building a smart contract or a dApp. The collections contract and the SDK are a really good place to look to kind of understand how the contract can interface with the SDK. Take those, copy the directories, and build off of them. So, and I have a couple examples here of what a collection looks like. So in the case of the puppets that a lot of you are probably familiar with, we have attributes, right? And there are 6 of them, and they follow kind of the standard SRD20 attributes. Your strength, charisma, intelligence, wisdom, dexterity, constitution, right? Those in modern times, the common way to roll for those is to roll 4 6-sided dice and then add the 3 highest numbers. Okay. Computationally, that's something you can do. You can have a random number generator roll d4 over and over and over again, right? And you can return with it. And we actually have that functionality in the dice contract for any type of die. People can use that. We decided to use the collection for that instead. And what we effectively did And this is the JSON representation of a collection. We've put the probability distribution here as constants for the collection values. Okay. And we've deployed this on mainnet. It's actually on all the networks. And with the collection contract, we have a number of features that allow us to do things like sampling. So we can do a uniform sample from this collection, which means we just pick a random value out of that array and we return it, right? And when you sample from this is a discrete inverse distribution. When you uniformly sample across it, you sample from that distribution. So in this case, we can very cheaply sample from what would be a relatively computationally intensive process. So that's a good example of a use case for the collections. I should note that, and you'll notice here, there's an array of these. If you want to add a collection, when you run that npm run initialize, all you have to do is add another file here. So, you can add an increment number, add another file, and when you run the initialized script, it'll automatically deploy that collection to the blockchain. Okay? And that occurs to any network, by the way. I'm going to show you a couple other examples. So this one is kind of boring. I think it's interesting because I like stats, but others might not. Here's another example that we actually also use in the puppets, right? So this is different character archetypes. So these are kind of a reference to kind of your standard 12 character archetypes in any story, right? So these are also a constant on the Neo blockchain now on all networks. One of the value propositions for this is that if you are just starting out as a developer in the ecosystem, and this isn't so big of an issue right now, but you can imagine the cost of loading constants into your smart contract. Like if you needed, here's another one with colors, right? If you needed to load this data onto the contract, here's a personality type one, right? It could be very expensive for you starting out. So we attempt to preload these libraries onto the network so anybody can use them and reference them using a pointer instead. So it's a lot more computationally efficient. It's also cheaper for new developers. As in theory, if prices increase for invocations, then it's valuable. It's also nice to have, again, a common resource that multiple projects are using for a number of reasons that are probably pretty obvious to this community. So that's really what the collections are, right? We've also used collections. There's a nice article that went out the other day. This is a TypeScript recipes directory on fair sampling. This also uses the collection, right? You'll notice here we're using this method called sample from runtime collection. And in this, with very little code, we fairly use the blockchain to sample winners for an airdrop. And we'll actually be using the same code for the Puppet airdrop for this event as well. Okay, so this is a good example. If you're a developer, you can kind of reference that. The methods and integrations are identical, whether for implementing this, whether you're doing a contract call from the smart contract or using the SDK. So blockchain use shouldn't be limited just to the contract developers. If you're a front-end developer, you can also work with prompts and build a lot of value. Okay, and this is one good example of that, since there was no blockchain development or really even fundamental understanding required to implement this use case. Okay, so now let's jump to the generators, and we're going more and more complicated in the props contracts, by the way. And they also build on top of each other. I probably should have done this before the call, but I want to show a diagram really quick. And actually, let's just do this. I guess you guys probably aren't watching me talk, you're looking at my screen, but I was going to pull the whiteboard up. Okay, so the way this works, and we'll use the puppets as an example here. For puppets, because this, I don't think we communicated very well. You have this dice contract, right? Okay. And I'm going to build up what the puppet call stack looks like so you can see when I'm talking about like decentralized application packages, this is kind of what I mean, right? And this is why when a lot of people who have been involved in the planning and the work on this project, when they talk about it, they kind of talk about it as like, this is sort of what the smart economy means to COZ. Okay. So you have a dice contract. We also have a collections contract. Right. Way over here, I guess it's not way over, we have a puppet. We have the puppet contract. Okay. When we minted almost 5,000 of these puppets to the chain, we were actually calling, and here's the generator contract. We were actually calling the puppet contract was calling the generator contract to build out the traits procedurally. Okay. It was also calling the collection contract to generate your attributes using that distribution that I mentioned, that distribution collection, and to random uniform sample from that distribution, the collections contract is calling the dice. Okay. Now, the puppet contract is also calling the dice contract. Okay. The puppet contract calls the dice contract to the sample for what is it calling it for? I guess I can just check it, or I can just say the puppet contract calls the dice contract. The reasoning kind of eludes me for now. The generator contract also calls both the collections contract and the dice contract. And it does that. The generator contract calls the collections contract because all of the trait values are actually stored in collections. So I remember I pulled up that there's like the colors one, there's the personality archetypes, things like that. The generator contract is actually using a pointer to a collection ID and a specific index to reference the value. People can use this if you want to have like a static class asset that's serialized and stored. You can use it that way, for example. In our case, we're just using it for a simple, like a string value, right? It's also using the dice contract to run probabilities, right? So each of the traits has different probabilities to drop different things. It's using the dice contract to determine what collection object should be returned, since they all use a nonlinear distribution. Every trait and every attribute is not uniformly rare, right? So this is really, and this is kind of a messy diagram, but this really shows what we perceive. This is kind of our idea of the smart economy vision. So you can imagine all of these dApps interconnected and working together seamlessly. That's what we're building tools towards. So the dice and the collections we've gone through, those are probably our two simplest ones. The generator is the one that we will probably spend some time on discussing. It has a lot of features. And then the puppets contract, if I'm being honest, is actually relatively simple because all of the work is being done by these other three contracts. So the idea, and with the puppets, the idea is that we've gone through the trouble of minting all of these and adding the features. So there is a provably fair distribution. Now with those features, we're interested in seeing what developers can do with them, in addition to the actual contracts, the other prompts contracts as well. So jumping back to our code, let's talk about generators. So generators are going to work similar to collections. We've simplified in this project ecosystem how to build generators. You can have a load file, like a JSON file, to load your generators off of when you're priming the network. You can also use code directly through the SDK to do it, and you can also create generators and instances on contract call directly on the contract as well. So this generator here, this is a very complicated example. This is the one that built the puppets, for example. And I believe, I'm not going to count them all. There are a lot of different traits. Broadly speaking, features here, right? You have a label for your generator. There's a base generator fee. And this is a really important concept that is it's very unique to this specific contract in the ecosystem, although the Puppet also implements it. The generator contract, you can't reproduce the run, even in a test invoke. So the code is branching, which means every time you run this code, this contract invocation, to mint from the generator, the gas fee will actually be different. And that includes the test invoke. So when you do a test invoke to try to predict what the gas fee is, it will actually be different every single time, which introduces some complexity in terms of how to handle that. Because if you can't predict how much it's going to cost, you don't know how much gas to attach, right? So what we do in the generator is we peg the gas, and you'll notice on Neo dashboard, and I think the gas maximalists are probably going to love this concept. Around the time of the big Puppet airdrop, the gas burn increased substantially. And the reason the gas burn increased substantially is because what we do in the contract is we take a snapshot of the gas cost for the compute at the very end of the contract run. And then we look at the difference between what it costs and what the target price for that generator is, and then we burn the excess. And what that allows us to do is run branching or non-deterministic code with a deterministic fee, right? And this is also a really important concept regarding exploiting branching code in a decentralized environment, since one common way to exploit these systems in the past was to run code but attach a fee only a certain amount to kind of ensure that your invocation either failed or performed in a certain way that you wanted. You can't really do that with this contract because it's going to try to burn your gas also at the end. So the invocations all cost the same, whether you are trying to, whether you run it takes a very simple path or a very long one. So that's how we solve that problem. In the code, I can show you where that is really quickly, because I think it's a very important and valuable feature for us in the ecosystem. And I'm sorry for jumping around here. I wish I could just share an entire screen. So now we're in PyCharm. And I'm just going to jump into the generator. It's going to be an instance. Okay. It's a name here, I believe. Yeah, so you'll see here that we have end gas, which is looking at this gas left attribute, right? And then we're looking at the compute cost, which is how much gas you started with, which was initially attached, minus the end gas, right? And then we calculate the burn amount based on what the amount that the user set was and the compute cost, and then we burn the gas. So this is a really kind of cool feature of the smart contract that has some pretty big implications regarding non-deterministic code executions in our ecosystem. So, right, that was a fun tangent. So jumping back to props in WebStorm, we can talk about the generators a little bit. So generators are, the way I would describe them is procedural event executors. And they can run in a bunch of different ways. So as I mentioned in the puppets, all of the traits that were minted on each puppet were run on a single generator, and that's this generator here. I mentioned that they use a pointer to a collection index. So you'll see in this case, right, there's the collection ID, which is 3, and index 0. So if we went in here, right, and I'm aware this is kind of overly abstracted, but for this example and from a tooling perspective, it does make sense. If we went into collection 3 and index 0, blue. So that value in that generator, if that event was triggered, would be blue. Right? The value would go to the collection, grab that value, and return it as blue. Right? There are a bunch of different modes you can run generators in. And I guess I should probably explain at a higher level how this is laid out. So there's the label. This is the base generator fee, which is the default. Okay, that's what the creator of this generator kind of defined as the base fee. Now, that fee can change over time based on the way that the consensus nodes vote, right? So the consensus nodes may change the base fee, for example, which would change for the entire Neo blockchain, which would change the invocation cost, which could throw this off, right? That's why we also have this concept of class instancing in our smart contracts, which is an even more advanced technique that we'll get to hopefully in the next couple minutes. But I think explaining the generators is probably worth spending a little bit more time on. So for traits, here you can see the label. So in the case of the puppets, right, there's a color trait. And in this case, everybody has a color trait, right? You can mint arrays, so which mint multiple values from your same option list. Slots is an indicator of that, right? If you have 2 slots, it will potentially mint up to 2 trait values in an array for that object. So really, like, if we went in and changed this number to 2 and minted puppets, they would end up with up in this case, there's a guarantee that they get a color, so they would end up with 2 colors, right? They would actually get an array returned for the color attribute or trait, and that's all you would have to do is change that value, right? For trait levels, so the way this works, this number is on a scale of 1 million, the drop score is. And what that is saying is, and I'm going to collapse this down because you'll see there are a bunch of these here. So on a roll of 1 to a million, it's 0 to a 99999, whatever, right? On that roll, if the roll or the result when rolling for color is less than this number, mint from this trait level. Okay, uniformly sample from this array. So, and what it will do is it'll go through each trait level. So up here you can see there's a really rare scenario here where a roll on a 1,000,000-sided die, you have to roll between this value and this value to get this result. And in this case, this is the ghost color, right? Okay, so that's how the rolling works on this. And again, I owe you guys some docs on how this works because I'm sure there's some people who have glazed over eyes right now. Okay, so that's how that works. We also have a mint mode here, and the mint mode is really powerful. So a mint mode of 0 runs in a choose structure or format, right? So if you're familiar with sampling approaches, a 0 effectively pulls the value and then leaves that value as an option in the array, right? If mint mode is not set, if mint mode is 1, it does not behave that way. It will actually sample from that trait level, and it will not replace the value. So in this way, you can simulate a deck of cards, for example. And the really cool thing about this is that you can actually have a generator which simulates multiple decks of cards with different types. And all you're doing is selecting different traits. So you could actually have here, you could have 5 different decks of cards, and there's a different probability of sampling from each one, and they all go to this trait, right? Or you could have 5 different traits with 5 different types of decks of cards, or 5 different traits. Some have this it's called a pick mode. Some have this, like, you can only pick it once, it's not replaced experience, and others have something where they can continuously sample from the trait levels. It opens up a lot of opportunity there. We actually considered doing a demo for this workshop with cards and just dumping a card game and running it out of a generator by default. And you can probably expect very soon for there to be some generators up in the ecosystem, which are collections and generators which represent decks of cards for many different types of games. But that works out of the box. You actually don't even need to do anything on a smart contract. You can completely, speaking of SDK developers, or like if you're a React dev, for example, or JavaScript developer in general, you can build a deck of cards on the blockchain and sample from it as if it were a deck of cards without doing any contract development. You can just use the native generator features for that. You can just run it just like a deck. Okay, and it'll fairly sample for you. Okay, so let's talk about traits now. So this is one level down. And each one of these objects here represents an individual value, right? We looked before. So in this mode or type, right, it's a pointer to a collection index. And in this case, it was blue. we have these two different fields here, which are important for the generator. We have a type and a max mint. Currently, there are 4 different types of events or traits in our generators. And let's see if I can remember them all off the top of my head, since I don't use them all. And I'll actually show you a different one in a second. This one, type 0, is the first one. It does a contract call to a collection and returns the value of the index, right? There is another one, which, and I think it's probably easier for me just to pull it up, and I'll show you. I should note that a lot of our code in the SDK is pretty well documented, and these methods are actually better documented in the SDK currently than in the smart contracts. That documentation is also up on props.coz.io. So we have docstring that is formatted and rendered there. For developers, so here are our 4 different types for generators for events. So we have the collection pointer, which I mentioned earlier, right? So it goes off to a collection and it samples. We also have an instance call, and the instance call is something that I mentioned before. I alluded to it, where we have class instancing. I don't think we're going to have time to get to that. That's also a bit of an advanced topic. Effectively, you know how I mentioned earlier on where we kind of perceive these as decentralized application packages that people can use? Well, the storage also counts as that in some of these contracts. So in the case of the generator, for example, the generator itself, so this object right here, this is deployed on mainnet, and it can be freely used by anybody. So people can go, this is a very expensive generator. You can go and you could use the same generator that we use for Puppets for something else, right? I would advise you to create your own generators, but you can do that. And that's the case for every generator, right? If you want something that's more secure, there are ways to do that by like securing payload, for example. In any case, the storage values are also publicly available for this specific contract. The thing that comes along with that, though, is a security risk, right? And this specifically is very important concept for the generators, where they're probabilistically making contract invocations, right? And there's a stateful component. So for generators, when you want to create a generator, if you had to push all of this onto the chain every time you wanted to use it, it would be extremely expensive, right? You can imagine if we did that 4,000 times or 5,000 times for the Puppet, it would be very, very complicated. Well, it'd be very expensive for us, but it also would be very inefficient for the network and the community. So we deploy it one time, and then we create an instance of that generator, and then we sample from the instance. And the instance of that generator is very similar to a class instance, right? And there are a bunch of different features associated with the generator instance, one of which that we mentioned before is the ability to change that base gas fee for your instance. So in the case of the consensus nodes voting to triple the gas, like the base execution fee, for example, if people are using instances of generators, they could update their generator instance to accommodate that change, that financial change, right? And still be able to function in the ecosystem. The problem with this also, though, is that because the generators are stateful, there are some features similar to like the pick, for example, where storage is used to manage the state of your generator instance. We have to have something called an instance call. And I'm actually going to just kind of gloss over this concept right now so we can get moving. But an instance call, it's basically a contract call with a code that needs to be used so that instances can whitelist each other for access. Okay. The next one is event value, and I'm going to show an example of this really quickly. That's the simplest version, and you can see mint type 2, right? And the argument is literally just a value. Okay. So you can just stick a fixed value in there and it will return the value. Okay. The next one on that list is sample from, and this does that. It invokes a collection and then it uniformly samples from a collection. So I mentioned that we use the collections in the puppets contract for the attributes. If we wanted to, we could have used one generator to generate the entire Puppet NFT. And we would have done that by creating all those basics attributes like charisma, intelligence, wisdom, etc. And we would have set a single value on that trait. And it would have been using the collection sample from, and it would have pointed to that 46 collection, right? And then you could run one contract invocation to the generator, and it would return everything. The Puppet is meant to be kind of an example of how to use these contracts, though. So we wanted to make sure there's a wide range of uses. So lots of different ways to use these tools. The instance call is also really important because it is a format of the contract call. So you can, as a game developer, for example, or actually as any kind of developer, you can imagine that could be used for like a chest, for example, or probabilistic minting of NFTs, right? You can use this tool to provide like a 5% chance of some event happening in a different smart contract somewhere else, right? So maybe there's a chance that an earthquake happens and you have like an environment smart contract, or there's a chance that, someone hits a home run and there are like future implications in the ecosystem. It's not just like a return the value type of experience. This tool can handle that. Another good example of the use of the instance calls, and we have a test for this as an example, you can recursively call generators. So you can have one generator call another generator and another generator and another generator to build out objects of pretty immense complexity, which can also then go out and call other smart contracts, right? The instance call, I should note, the value that comes back on that object that when you mint is the response of whatever the instance method that called is. So if it called a chest and you have the response to be like the amount that was in the chest, that'll show up on the JSON object result. So you can go in and use that for future computation as well. Right, so that's how generators work. We could probably spend an entire workshop on those. But I want to mint some puppets. So I'm just going to run here, mint puppets. We're going to mint them. And here you can see over here, here's where our transaction happens to be showing up. And you'll see right here where this is with that instance, right? So creating a generator instance using that generator one. You'll see it's minting them. And you'll see over here that we're actually pushing, although I limited 50. So you'll see there are a bunch of transactions here going in. And here are our puppets. So in one command we can do this. And you can repeat it pretty quickly in your ecosystem as well. So it should only take those 5 commands or so. You can mint a bunch of puppets and start interfacing with them. The interface for the puppets themselves is also pretty robust. In this case, this is the response This is what the properties method returns, and it's in a nice format for ingestion by applications like exchanges, for example, wallets, explorers. Can very easily, if I wanted to, and I'm just running this script mint puppets right here, right? We're getting the properties. I could use a different method because we expose another format, and it is get puppet JSON. Sorry, my formatting is incorrect. And you'll notice, so this is a flat architecture or JSON structure, right, where we use a dot notation. If I were to run this one, using this get puppet JSON instead, it's a more developer-friendly format, so the attributes are nested and the traits are all nested, right? And this is running that generator that I mentioned on chain, and it's minting. Right, and you'll see we had already minted 50, so it's going to mint a bunch more, and then it'll spin it back. And you'll see this format is a little more easy to digest. And it's just this get puppet JSON, and it just formats it. This method, by the way, the properties and get puppet JSON are in the SDK. They are also public methods on the contract. So you can make a contract call and get either one of these formats as in code. And we actually use that in the example that I'll be pushing up soon in the turn-based game. We actually use this format instead. Because I prefer the nested structure personally, but so that's how that works. Let's see some other valuable things here. I guess we're starting to run over. Yeah, so I guess if we're going to try to wrap up here, what I would also recommend people do is look at some of the tests in the SDK, and also just look at the SDK in general, because I think the SDK probably has more definition. The tests certainly do, but notice we have the entire thing fully built out with every method that's accessible. I kind of focus on props very heavily here, or on the contract side. When you are building a contract out, if you want to build out the SDK, which you probably will because you'll have a front end, we also have a lot of really easy to use tools in the SDK directory, to the point where, if I'm being honest, it actually makes interfacing, which used to be the hardest part, I think, of building in this ecosystem, kind of trivial. It took me about an hour to build up not even an hour actually, to build up the SDK for the game project that will be a demo. Granted, it's a simple one, but what we've effectively done here is we've added these template files in two locations. So there's an API level template file. It's called template.ts. And at the wrapper layer, so just template.ts capital. And we've added methods. So you can see this at the API level. We've added a single method as an example. We have taken pretty much in props all of the guesswork out of formatting your data. Okay, so you can take this and directly interface with your project, with your smart contract, and we will handle the response formatting, we will handle the invocation formatting and the payload formatting. We actually this method format will automatically, and it will actually give you both options to toggle between a test invoke and a published contract invocation. So you don't even need to focus on that. In this case, if you want it to run as just a test invoke, you don't provide a signer, right? If you want to publish the transaction to the network, you add a signer and it'll go. We've even included for all of the common formats that you need or that you would be using, we've included an example for how to format them, right? The only thing you really need to add is the method name here. All of this configuration, like the network magic, your script hash or node, all of that, we actually also provide support for at the API layer. But this will handle contract invocations and return the result of the invocation in a formatted way. So you don't have to deal with like the base64 encoding. You don't have to deal with whether it's hex, it's an integer hex string, if it's an integer, it's uint 160, etc. At the API level, we also provide some a helper template, right? When you go in, remember when I was talking about deploying your smart contract, all you need to do is record that script hash and just stick it right there. For local, for your private network, here for your mainnet, because your mainnet deployment will probably have a different script hash, and for testnet, and you'll have all of the same functionality that we have with the props project for your smart contract. It automatically you provide a node, or actually you don't even provide a node anymore. You effectively just provide, and I'll show you this in the test. Actually, I can just show you in this script. All that you need to provide now is your network. Okay, and the network is just it's an enum. So SDK, right, types network options. So you just say, is it testnet, mainnet, or localnet? And it'll automatically connect. It'll manage and facilitate the network magic communication. It'll even pick the node for you, right? And then you can start invoking the contract. So you'll see here, right, we're spinning up a Puppet interface, we're initializing it, generator, we're initializing it, and then that's all there is to it, and then we're invoking the contract. So very, very straightforward. We even provide, so a method here, there's a helper method in the SDK called txdidcomplete, and that will return, it will parse the invocation log, and it will return all the notifications off of your smart contract, and it'll return the response value as well as the gas cost. So what we've tried to do is package these, a lot of these pieces that people have had issues with over the years. And I realize there's still a lot of work for us to do here, but this does represent a pretty comprehensive experience for getting started with contract development, or just actually general application development in the Neo ecosystem. So I think there are a lot of other things for me to go through on this. We didn't really touch base on the instancing, for example, but I'm hoping to fill some of that in with either documentation, or we can do a follow-up workshop with even more concepts, or in the Discord channels as well. I think we can probably call it there. Maybe if there are any questions.
Okay. Thanks for Tyler's presentation, and all the audience. If you have any questions, you can write them in the devlog test channel. I have saw some questions, Tyler. The first one is from Robert. Can you explain to everyone the importance of using the props random number generator instead of trying to create your own? Also, it's a dice contract and IO code.
The dice contract is not, so it wraps the native random number generator functionality, which is implemented on Neo. You can use it's an interop. You can use the random number generator that is built in. The goal of the dice contract is to make it easier to interface with. The random number the random number generation feature on Neo is pretty good. The Neo team released a pretty extensive and detailed article outlining the capabilities of it for Neoverse. I believe that was the first use case. The generator is effectively generating entropy, right? All we do is we take that entropy and we package it into commonly used formats and methods so that it's easy for developers to integrate with. It has a repeatable range of values that the user can define. It's tested as uniform. You can select like how many responses you want back. We actually have some efficiency methods as well in there, so you could use like the raw get random method, for example, and then you can even feed. You can actually feed that into the dice contract to use that as your entropy, and then you can tell it how much you want. Or what ranges you want, and it'll actually take that entropy to use that for the calculation instead, so it's cheaper. But yeah, it's actually a pretty simple contract. The goal is just to expose, user experience enhancements, right? So things like a sample between or a ran between, where you can kind of input two values and it'll return values from between those two numbers, things like that. That's really where the value proposition is for that. I think, just before I forget, the people that are on the call, if you want to just post your address in the Discord or maybe DM it, maybe if you send me a direct message with your address, I'm going to snapshot the participant list here. So if you send me your address in a DM, I will use that for the airdrop. And then maybe in like 2 hours, based on the list that I get, we can do the airdrop off of it. So make sure to send me your N3 address. Okay. So that was that comment. Let's see. So that's really what that's for.
Okay. Okay, thank you. Yeah, there is another question from Rob. First, what SDK integrates with smart contract in the new N3 ecosystem from off-chain applications?
Yeah, so there are actually quite a few generic, I guess I wouldn't call them generic, there are N3 SDKs. So depending on the language you want to pick, if you are, for example, NeoGo, Neal3j for Java, Neon.js is JavaScript, Mamba is for Python, right? Those are the base level SDKs. We also, for props, we use TypeScript. So if you want to develop with props, with this ecosystem, this one is the SDK is JavaScript based, although we will probably be adding other languages. If you go to the props website, just props.cz.io, and you click getting started, this will walk you through kind of the overall project and how to do it. But if you click on the SDK and go to the TypeScript SDK, it'll actually tell you where to go. So it's here. So it's just at cityofzion/props, and that will pull the props SDK, which is kind of the code that I've been showing where, I showed you here. It's very, very easy to interface. We have a couple quick starts, for example, in the SDK documentation. So here it's like puppet.symbol, puppet.total supply, puppet.decimals. It's very, very succinct. So that's where the SDK is located for this type of project, or this specific project, where it's abstract it up a little bit more. And then the GitHub, there's the props GitHub repository, and on the City of Zion GitHub, which is where the source is. So if you wanted to add or build out an interface for other smart contracts, you could reference that or use that code to fork.
Okay, got it. There are some questions from Robert. The first one is, where are the images stored for the main puppies? For example, Neofs or another place?
Yeah, so the puppets are fun because the images are actually stored on S3. They're not stored in a decentralized way. And this is actually, there are a couple of reasons for that. So the first and probably the most important reason is that I appreciate some of the positive response about the images for the puppets. Every piece of information of value about the puppets is stored on chain. The image is actually just a representation of the data that is stored on chain, and for that matter, it's actually reproducible. Something that I didn't really show you guys, and I don't think this has been gone through about the puppets very much, is there's a hash at the bottom right of your corner that's actually a seed attribute. So every puppet NFT also has a seed attribute, which can be used for kind of expansion. So even the image itself is generated using the seed, but the actual the intrinsic value of the puppet is actually stored on chain. That's why we call it a utility as opposed to an NFT. So there's no real inherent value in the image. The image is just a representation of what the data was on chain. And kind of from this workshop, I've kind of showed the entire generation process is also done on chain. So the image is generated after the puppet is minted. So in our airdrop, people may remember we airdropped 5,000 puppets, and some of them didn't even. You would go to the Explorer and look, and they wouldn't have an image. Right. The reason they don't have an image is because the image didn't even exist at the time the puppet was generated. The attributes and the puppet was minted, and then a script went and grabbed the information for that puppet and generated the image to represent it. And I think this is an important point, that the puppets are really meant to be, and some people are kind of familiar, or maybe familiar with like the Loop project, for example, on Ethereum. This is meant to be kind of a logical next step in that type of project, where we really make no claims about what the attributes are for or the traits are for. We are simply providing them as extensions of the user's addresses and the accounts in the ecosystem for anybody to grab and decide what they want to do with them, right? All of the color, like the rarity colors and things like that on the traits, or in Mercurial apps, there's a rarity points indicator. All those are doing or indicating the probability of certain things on the puppet itself, but all of those attributes are baked into the chain. They were generated on chain. They stay on chain. Anybody's welcome to come along and do another render or a different image render of the puppets, or build off of them to maybe have a persona which is derivative of the puppets that is used in some application. The other important concept here, and this is something we've discussed adding, is a Neofs alias contract similar to NNS, but for objects, where you could have like scope storage, for example, because and then you could have like a one-shot update kind of approach, because the puppets because we store it, there's the image URI, right? So currently all puppets, as when they're minted, they are immutable. So we can't even modify the NFTs themselves, right? We can't modify the distributions. We can't game the system. COZ, for example, is minted. I think we have 3 puppets right now. They're all common. So that gives you an idea. Like, we can't really game that system at all. There's no control. It's immutable. As a result, though, there is a downside to that, and that downside is that we need to have an image URI with the NFT, or at least we considered not doing it. We chose to have an image. That image URI or path needs to be known at the time the puppet is minted, right? But we can't know if we wanted to use Neofs, which uses hashing, which most good storage systems use. We would need to know what the image is, the hash of the image is at the time that the attributes are created. But we need to know the attributes in order to generate the image. So there's a circular dependency there. So it's actually not feasible right now for us to deploy them in a decentralized way. But again, I kind of defer back to my initial point that the images aren't valuable. As I mentioned, so I showed here when we were minting puppets, every piece of information of any value is actually stored on chain. Even the physical representation that we stick on there, you'll notice that the shadows of the puppet itself actually lines up with the correct value. That's because they're mathematically accurate in 3D space to represent the attributes that are on chain. So the shadow that's cast is actually a representation of your radar plot for the attributes of the NFT. So there's nothing intrinsically valuable about the cards, although I have gotten some positive feedback that people like the look, and I do think our designer did a nice job on them. But it's a very long answer way to say that, at least for the puppets, the image doesn't actually matter. The intrinsic attributes are valuable, or may not be. Right? It kind of depends on what ecosystem developers do with them. I can tell you the COZ has some projects where we will be using them, as well as the other props. It would be nice to see some other developers use them as well. We have seed funding to support developers to use them as well, that anybody here is eligible for. So if you have a project that uses them, either just as a front end application, or you want to use them in a more involved way, like with contracts, for example, then we have seed funding available for those types of initiatives.
Okay,
So,
cool. Cool. Here is the second question from Robert. Is there a good GitHub repository that has an example of using props from browser-side JavaScript without needing a backend server? If so, can you share us the link?
Yeah, so so Mercurial Apps is probably the first implementation. However, they have a server or backend implementation. The first front end implementation that I would probably reference or point people to is this recipe, which has fair sampling, right? So this example will allow people to. It's kind of a good use case. It's not it doesn't have an interface, right? It's a script, but it does show how to cleanly interface with the props contracts. It does not expose how to interface with the puppets. However, the puppet interface is the exact same. The code would be identical to, I can show you this. We do have examples in the GitHub, and I can pull that up. So if you go into the SDK, there are a couple examples in the scripts. There's some in the SDK as well. If you go into the tests, right, there's a Puppet test, and it'll kind of show you, right, so you want to initialize the Puppet, but that's really the only thing you need there. And then here are the examples, right? So decimals, simple, total supply. If you want to get the balance of an address, the total, this is to create a generator. Minting. Here is probably one that you would be interested in, right? If you're trying to pull all the puppets, you can do something like this. So there are examples of code, like some small micro recipes. We don't have an application up as a reference yet. We are pretty motivated to add native Wallet Connect support into the SDK, so developers can just pick it up and start requesting signatures from people to integrate, and then also having example front-end application which uses props as well as part of that folder or that project for people to get started with. Currently, the furthest towards the what I would call the client or retail user that we have exposure for is the SDK level. Yeah. Soon though.
Okay. Okay, thank you. That's the third question from remote. Can't you use the N3 allotted contracts list feature instead of using event instance call to grant invoke access to other contracts?
Can't you use N3 allowed contracts list feature instead of event instance call? You can't. And the reason for this is that the access is actually at an instance level, not at a global contract level. There's also some inherent updatability considerations there as well, right? So because the contract is designed to be permissionless, if we held the keys for the generators, we would be constantly updating that or needing to maintain that for everyone who wants to use the generator. The issue isn't at a contract call level. It's one level lower than that, right? So you can imagine a scenario, GPDs. So imagine a scenario where you and I were both using the generator contract, and we were both using maybe two different generators, for example, and we had two different instances of generators, right? So you were using an instance of a generator, I was using an instance of a generator. Those instances have stateful mechanics in them. We didn't go into this, but in a lot of detail because of the time, but there is also a feature in the props contract, and I can jump to it really quickly here, just to show you guys what I'm talking about. There's the ability to set, there's the picking feature, which I mentioned. There's also that max mint, and in every example we showed, it was -1, right? You can actually set an explicit maximum for how many times something can show up. And we actually see that, and I'll show you really quickly what that looks like in the Puppet. So if you crank the rarity points or sort by rarity, these guys here, so this is a fun one that I really like. So this is like the Satoshi Nakamoto one, right? And it's kind of funny because it has the creator archetype. This trait here is one of those max mint one. So and it may never show up because of the probability component, but once that shows up, it can't show up again. Okay, for my generator instance. The problem shows up when, let's say, you want to call your generator from a contract. Well, if we've whitelisted the contract, which is making the call, then that opens up every single generator instance to being called, including my own, right? And I may not want you to call my generator instance, for example, because I have this like state which has already been triggered in mine. So it would, without the instance call feature and the whitelisting, which is actually very similar to, if I'm being honest, the allowed contracts feature, it's just one level lower. It's at an instance. It's like an allowed instances feature, if you want to think of it that way. The goal is just to prevent unauthorized users from accessing my instance, because the contract level access control doesn't apply here, because it's technically the same. You may have 5 different users coming from the same contract. So that's the purpose.
Okay.
I hope that answered your question. It's kind of, the instance call is a little complicated. But that's really the main reason, right? There's a security risk because of the stateful nature of the instances themselves, where you don't want anybody being able to call your contract through another contract. So there's a risk factor there. That's why we have that feature. Yep, exactly as you described. And we do have, there is that ability to have a completely open instance where you basically just have wide open instancing. You can also set it so that it only allows access from the entry point, meaning only users can directly invoke the instance. It doesn't accept access from anybody else or from other contracts. There are a couple different features in instancing that are kind of important. The generators can do a lot. We talked about the cards example, but we also talked about a lot of granular features. And when you start adding those up together, there's quite a bit of utility in them. They're kind of probabilistic events. So.
Okay. I think that there is a final question from Robert. Tyler, please pronounce your GitHub username live now and on air.
Thank you.
Yeah.
I think it's Louisville. I think that's the stable pronunciation. If people look for me on Discord, I have the Mohawk.
That's a very interesting name, I think.
Yeah, it's nice because it was unique on every social platform.
Yeah.
It's also a palindrome, which makes it kind of cool. Unfortunately, it's really easy to use to exploit people, right? So L's look like ones, and there are a bunch of them, so you can remove one, you can add one, you can swap one out. There are a lot of combinations that look legitimate but aren't. But yeah, if you look for the Mohawked person on Discord, that's me. So
okay. I think that's all from today's workshop. Thanks, Tyler, and thanks, everyone.
Yeah, I look forward to seeing what you guys build with it. And like I said, there is support, both financial and developer, available for projects that want to build in the ecosystem. So thanks, everybody.
Thank you. See you next time.